So good afternoon, everyone. I would like to invite my friend Nanda Gopal Raha for today's talk. So please come, Nanda Gopal.
Good afternoon, everyone. This is my topic or title of my talk, Neutron pattern to spin lattice, macroscopic analysis. I'm this third year student, Presidency Physics Department. So this is the outline of my work or my presentation. Many things are written there. So don't waste time too much. So jump to the introduction. So first, we need to know what is macroscopic. A process in which we neutron directly and get reflected sounding, and we detect that under what area what kind of something also is there by so principle is nuclear force the main thing to guide that internet. So why need that they are they are only have their main need. So we as example the we have nuclear forces. So we use neutron to neutron study. This is the you can clearly see neutron showing by this is a polarizer and this is focusing and hitting the center with some angle get reflected and detector detects that maybe if there are no samples so we observe pattern here only but as we have material so that get reflected with some angle neutron here and maybe here also possibly detect neutron. So this information we get by data it provides us what the material about is there. So theoretical model or mathematical model. So then I you four elements. There. So one is that I will explain later, but we use four and this it's that this we have one basically it is and for these four methods four members yeah and this is a problem which is from this event and I did that and this is magnetic moment and for this they are red dot or red you red division and by that of this type of expression I can by using this method, especially we play, we use around it in we use this level to test their value of their capitalization. This high level of what things planet and are of they are the this and this get equation of this we need to calculate that is basically a test particle we need this this is the cloud in actually we use four methods there and this time imagine this particular is something guided so we get that equation we need solve numerical. So I use special integration method solve that integration. Each step by step. I use I need some initial conditions which is given by 1 1 activity is the action and you can see there is potential action in both direction and also one for this slide we use various initial condition and this is line and both sides are same in both sides left and right. So this is the numerical simulation method I use for that. So I previously mentioned you that I use four ring magnets to interpolate the plane of how neutrons are moving or something test particle is moving. So I need to fix that four magnets in under the carrom board. This is the carrom board setup. You can clearly see four ring magnets. This is the experimental design of my theoretical model. I use four ring magnets. I mentioned previously that four magnets are attached below of carrom board. This is under side view of how carrom boards are magnets are arranged in this this type. And this is the test particle or neutron-like particle I used. This is also a ring magnet. This is smaller ring magnet. Due to this magnetic field, I need to choose a small ring magnet. So the dipole moment is lesser than this ring magnets. So the particle can freely move with x and y directions that previously you see that this I took kinetic term x dot square and y dot square because of this. So the ring magnet can freely move with x and y directions. How the coordinates are chosen by I will explain later, or you can see the after this data or this slide. You got or know how to I use axis in there, and basically this magnet can freely move with this direction. That's the main reason. And this is the whole experimental setup of my work. And there is the camera. if the neutron like particle or the ring magnets can move with these directions, it captures by this, we easily capture. And there are four magnets, ring magnets are there in under this carrom board setup. There are feeds here, actually four types of ring magnets. And I especially use the tracker app or analyze to how to analyze frame by frame. I need to use a app to analyze the video which is kept here from here. So I got the velocity, acceleration, and position plot by this app. So demonstration of this app. Now, so uh, they are the coordinates I chosen use of this app, and here I give some initial velocity or initial force to this direction, especially this direction, and it's bended by because of this. There we have some magnets due to the potential use saw previously. The trajectories move or the pitch particle moves, and you can clearly see the x and y or scattering like plots here results. So in results, I use the theoretical model or theoretical simulation and get this type of results. And this is the various initial condition I mentioned previously that we need to use with various initial conditions, and by that we we get very interesting result in this region or x naught if the position is lesser than a and greater than minus a. In this region it behaves like convex lens analog types behavior, and others greater than or less than it's not, uh, it's behaves like diverging lens or diverging behavior or convex lens like analog behavior. So for this is especially for 1 0 axis or 1 0 symmetry axis, and this is a symmetric line or some symmetric line due to 1 1 symmetry or that previous I mentioned. Due to this symmetry, 1 1 symmetry, we got these types of symmetric lines or symmetric curve. You can clearly see this beyond these lines, and they are totally mirror image of each other. And also observe a special phenomena which is analogous to coherent backscattering or backscattering of neutron. If the velocity is not too high or lesser than some velocity, we get these types of graph or these types of condition, especially for which is especially actually it behaves like coherent backscattering due to low velocity and high potential. And this is experimental verification of my work for we use carrom board setup that's used saw previously. We use that and get these types of lensing like phenomena or convex lens like phenomena, observe that, and also diverging phenomena for this x naught is greater than minus a to a. And also if the velocity is not too high, we observe the backscattering phenomenon, which is due to the high potential and low velocity. Actually, this is observed. Actually, very good. Conclusion of my work. This work demonstrated macroscopic analog of neutron scattering using carrom setup and theoretical models in especially inverse cube dipole potential and Lagrangian mechanics closely match. That's experimental trajectories, and the setup clearly show lensing-like phenomenon, bending of trajectories, and the curves of magnetic due to magnetic potential, and it's similar kind of gravitational or optical lensing, like, and that system is low cost, educational. You can made it at home. You observe that phenomenon also, and classical especially highlights that the classical analogs are especially visualized, exploring usually quantum systems also. And future work, I want to test different types of lattice. You saw the a, a special kind of lattice that is four ring magnets or a square lattice. You can see that. And in future work, I am thinking that I use not only square lattice, also use triangular, hexagonal to explore the symmetry lines, that symmetry graphs that you saw previously, and also improve the budgets also, and especially investigate the lensing like phenomena. It's very interesting. Also, the coherent backscattering also lensing like phenomena, and this is my reference of my work. Griffiths and especially Griffith's book. I should highlight that I use formula from direct here, and I thank the Shoyat Minaj Hussain, Professor Shoyat Minaj Hussain, for this guidance, and MSR to provide me the internship opportunity. Also, to use my colleagues who helps me, especially Sound Kumar Mani. And this is all. And বড় করে একটা thank you. শেষ. Yeah. Or this. And yeah, this you can clearly see feel the magnetic potential here. They are vertically up. And you use a space particle towards the surface or in that plane. You can use the magnet also this types of orientation or spin orientation up or down also. I mean, you can use this particle, magnet is special. Your test magnet. How can you use how you that's it's your choice. If you use the magnetic dipole field or the dipole potential towards this direction, that should attract each other. If you take to that reverse, or if the potential is plus side on your if this particle's potential is minus side or minus z side, that should repel each other. Yeah. Yeah, so you can, yes, you can. And we solve the equation basically. I can't tell you how can see the trajectory changes. If your numerical simulation give you that, then how can that changed that bending trajectories or where the whole basically you get two holes in that field or that potential field. If you reverse these two magnets, your point is you are reversing these two point magnets. If you create that, got this potential term like there are two holes or two minima. So your test particle should go through the minima, or you may observe there are some lensing like phenomena in that hole only. But on that minima, you get some big holes or some lens like phenomena, or yeah, maybe anything else also. I can give you surely that what you get actual result. You should solve that equation. Hmm.
Any
Any
other
other
question?
question? Yeah. Oh, I explained to you first that why neutrons? Why neutrons? Because they have they are money. So if they are money, so they are only use their system on if you the last we expect there should be those are the diagram for and they are like this in that they are there is people who make for the negative feeling they are they want and this is gravity light spin on that because irrigation part it takes all one party for one it and I think availability and what in monitoring use electricity we want one full real mark to get and number